Hi, Jackson.
Hello.
All right, what do we got tonight?
I've already sent you a couple pictures for test review.
Yeah, open them up here. Start with 1 or 2?
Yes.
I don't have a 1.
2.
Start at 2? Okay.
Yeah, just start with 2.
All right.
1's already done.
Okay. So let's see, we have a house, and we're putting a rectangular dog kennel, and we have total of 60 meters of fencing. You're kidding me, which reminds me of a joke wire dog because they have 2 left feet. Okay. If the house serves as one side of the kennel, determine the greatest possible area that can be enclosed. Okay, how do we want to begin this?
Let the first side be X. Yeah, and then let the other one be 60 minus X.
Better, well, the other one would be 60 minus 2x, right?
Or 2X, yeah.
So what is the area?
Area equals X times 60 minus 2X.
Which is a quadratic. So the equation for the area is minus 2x squared plus 60x. And what's the vertex of this?
Let me get my calculator real quick.
You can do these on your calculator?
Yeah.
All right.
She told us today all word problems will be used with our calculator.
Okay. Because the way I would do it would be minus b over 2a, which would give me the x coordinate, and then I would substitute that into the function to come up with what the y coordinate, or actually the area coordinate, would be.
Alright, the intercept is, it's at the point 15, 450.
So
the maximum is 450.
So x is 15, which means the length must be 30. And multiplied together, you get 450. Okay. So they want 2 separate things for the vertex and the answer. So your vertex was what? Both coordinates?
15, 450.
And then the answer was 450?
Yeah.
Okay. I'm just curious why they have both. In other words, you would think the vertex having both coordinates would take care of the answer, but not really. Determine the greatest possible area, that's the y coordinate. So
where did you get that 30?
Because if X ended up being 15, and I had 60 meters of fencing. It had to be 15, 15, and 30. See? Why?
No.
Well, we got 60 meters of fencing. So
Yeah.
we got 15 there. We got 15 there.
Oh, yeah,
30,
okay, I see it
30
now.
left over for this side here.
Okay, I see it now.
Okay? All right. Okay. These get a little tricky. I'm glad this one came up, because otherwise I was going to go back to the one you sent me yesterday and look at question number 10. Most word problems, you can go directly to the last sentence in the paragraph to figure out what your variable is. In other words, you might be inclined to say the variable should be whatever price per copy we're going to charge. But that's not our variable. The variable we want to use is the number of 10-cent increases.
Okay.
You'll see it after we do one, I think. X, and in a situation like this, I would spell it out. If I was taking a test and doing this, I would want to know exactly what X was. So it's the number of 10-cent price increases, because we can either do 1, 2, 3, whatever.
Okay.
Okay? So our income, if you want to say the publisher's income, as a function of X is, well, what? We could sell it for 50,000 times 40 cents a copy, but we've decided we're going to raise it, but for every X, we're going to lose 5,000 circulation. So our total income is going to be 50,000, or 50,000 minus 5,000X. So there's our circulation. In other words, if X is 1, we're going to lose 5,000 customers. And we're going to increase the price to 50 cents a copy. If X is 2, we're going to lose 10,000 customers. But we're going to increase the price to 60 cents a copy.
Okay.
So this is our subscribers times, what are we going to charge them? To get our total revenue.
Should we just let X be 2?
Well, it'd be 40 cents plus X times 10 cents. Again, let's go through this. If X were 1, in other words, we're going to have 1 10-cent increase.
Okay.
So our subscribers will drop by 5,000, so we'll end up with 45,000 subscribers, and the cost will be 50 cents.
Okay.
Okay? So we can see right off the get-go that this actually results in more income. In other words, if you start with 50,000 and multiply it by 40 cents a copy, you get $20,000. If you start with 45,000 subscribers, but you charge them 50 cents a copy, well, it's 22,500. So that's more. But obviously, at some point, this thing would go to 0. In other words, if X were 10, we don't have any subscribers. So it doesn't matter how much they're paying. There's no income. So there's some magic number X that will optimize this function. Obviously, if we multiply that together, we have a quadratic. You can put your quadratic into your calculator, come up with...
We can just graph that as it is right now.
Okay, it works for you? You don't have to multiply it together. Okay. Didn't I try that the other night and I had problems doing it on mine?
The only thing you have to do is in between the sets of parentheses, you have to actually press the multiplication sign.
Ah, that's what I didn't do. Okay. Cool. Glad you figured that out. Ah, wow, that makes this a lot easier. We don't have to do the multiplication, although that's not the hard part of this problem. The hard part is setting it up. This is definitely a high-end word problem, difficulty-wise.
And just so you know, though, your Y value window should be above 1,000. I'm about to try 10,000.
Okay, I'll just let you do it. I won't do it unless you don't know how to do it. But it seems like you've learned how to use that grapher pretty good.
And I just lost my line. Hang on.
These are pretty common questions, too, that apply from anywhere from selling newspapers to running a subway system and having riders that you charge a fee. So these all tend to come in this flavor, where for every 10-cent price increase, you lose so many subscribers. So this is going to be a common type problem.
Okay.
And the key is just to make that variable the number of increases the number of whatever these price increases are. If you start there, the rest of it kind of becomes obvious. In other words, once I figured out what to let X equal, figuring out this wasn't that hard, and figuring out this wasn't that hard. You can kind of do it the way I did it, where I played around with a couple numbers, and it worked. Looks right.
I think I graphed my... Oh, no, okay. All right, never mind.
I am curious, they asked for the equation, so it's okay to give them the equation like this also? Without expanding it? Okay.
Yeah, that's right.
Do you want some help, or do you...
No, I'm just messing around with the window right now because I went up to 10,000 and I couldn't see it anymore, so I went down to 2,000.
These parabolas are hard to see. If you're on the wrong scale, they look like vertical lines or straight lines, is what I discovered last night.
Yeah, can you graph this because it's not working for me.
You want me to graph it on my calculator, or you want me to graph it on Wolfram Alpha for both of us to look at? Actually, that won't do you any good because they don't give you the min-max. So let me do it on my calculator. Did you figure out how to delete a curve that's already in there?
No, I still haven't figured it out.
Okay. It's all right. Okay, so let's see. So let me try doing it the way you did. 50,000 minus 5,000x. And then I got to go to the right and put the multiplication sign in hit the parentheses again and put 0.4 plus 0.1x. Actually, my very first window worked. Weird. Just a second.
What's your window?
Hold on a second. I got a spider on my desk. I got to figure out how to kill it. Ah! I hate that. When it runs away, you don't get it.
What kind of spider was it?
I don't know.
Was it big?
It wasn't a black widow or anything. But I do have a thing about spiders. All right.
Was it big?
It was about the size of a dime.
We get wolf spiders in my basement because I live in the valleys.
Oh man,
So.
those are horrible. I think I've seen a wolf spider around here also. Okay, let's see. My vertex came up, and let me see what my window is. Minus 10 to 200 on the x, and minus 200 to 40,000 on the y.
Wait, minus 200 to 40,000?
Uh-huh.
Alright, I have to retype it in because I think I deleted it by accident.
Okay. I can give you the vertex if you'd like.
Oh, there we go. Alright, I got it. Yeah, did you get your vertex as 3, 24,500?
Just a second. Let's see. I got to put my lower bound in. And wow, moving that thing over is not that easy, is it? Yeah, I got 3, 24,500.
All right.
So 24,500 is the answer. At least, yeah. Okay, let's open up the other one here. Problem is now that spider's down by my feet. I can feel stuff on my legs. I'm thinking it's crawling up my legs. All right, let's see what we got here. Which one is this? This one here?
So it wasn't a black widow?
I don't think so. No, in fact, it looked a little white. The whole spider was kind of white. It was like a...
We already did these together, but I just want to review on them again.
Okay. Yeah, I remember doing these. In fact, I've done these with you and the other student. Which one do you want to go? You just want to start from 14?
Yeah.
So what is our clue as to whether to use vertex or intercepts?
When they actually give you the intercepts in a clear manner, use intercept form, but if they don't, but they give you points, you use vertex.
Yeah, they're giving us pretty much 3 points for every one of these, and clearly one of them is not the vertex here. So
yeah.
We would use the intercept format here, which is A times x minus p times x minus q. So, here, let's go through this.
All right.
Just a second. Because these are all the same. You solve for A. In other words, once you decide what format you're going to use, then you put in the first intercept, which was 0. times the second intercept, which was 7. And then you put in the third point that they gave you right here, whose coordinates are 1 minus 12. What do we do with those? So right now we got y equal ax times x minus 7. And the point is 1 comma minus 12.
You'd sub in the negative 12 for the y, and then you'd put the 1 for the x.
Okay, so we got minus 12 equals a times minus 6. So a equals 2. And then our exact equation is y equals 2 times x minus 7.
So you don't have to write that 0?
No. In other words, x minus 0 is x.
Alright.
That's why it's written just as x there. Okay, let's look at 15. Which kind of format are we going to use on it?
Vertex, because they actually give us the vertex and 2 other points.
Okay.
Actually, one of the points is a y-intercept.
Which helps, actually, but let's see. Vertex format is y equals a times x minus h squared plus k. They give us the vertex, so what is it? 4 and minus 10. So what can I write?
Y equals a, and then x minus 4 minus 10. Oh yeah, I forgot the square, yeah.
Okay. And we only need one of these points, which they kind of make obvious because they give us the exact coordinates of it. We could use either one. Problem with this one here, the problem with this one is we can't be certain what that is. We would have to interpret the graph. Whereas over here they give us the 2 points. I guess we can assume that it's 10.
Yeah, I was going to say.
Yeah, I guess it is 10 because if you substitute, it has to be 0, 10. Okay, let's use 0 and 10 for our points. Because it has to be symmetrical.
Plug in the 10 for y and the 0 for x. So 10 equals a, 0 minus 4 squared minus 10.
Now what?
Move the 10 over so it's 20 equals 16a. And a equals
5.
Yeah, 5/4.
Okay. Yeah, and you'll notice that if you multiply that out from vertex format into standard format, that C is always your y-intercept.
Mm-hmm.
Okay? 16. What are we going to do with 16?
16 will be vertex form.
Okay. Tell me what to write.
So, the vertex is 4 comma negative 8. So it'd be y equals a x minus 4 and then minus minus 8 squared minus 8.
Okay.
And then the other point that we can use is the y-intercept, which is 0 comma negative 16. So we can do negative 16 equals a negative 4 squared minus 8. Move the 8 over, so 16a equals 8, negative 8. And then a equals negative 1/2.
Okay. You seem pretty competent at these. Why'd they give us that point there? I guess we could have used it. We could have used it. 2 minus 10 is easily read. Okay. 17, 18, and 19 are the same thing or not? No. Yeah, 17 we're going to use the intercept format. And this point. The only difficult is they use a fractional value, but that's no problem. This one, we're going to use what format?
Vertex.
And this point, which is easy to figure out. Let me know if you want to go.
Vertex as well.
Let me know if you want to go through each of these.
So 19, the vertex would be negative 5, 18.
Yep.
Yeah. Okay.
So that makes it x plus 5.
Yeah.
And then the point.
And then that bottom section that we don't have to do that. That's not on the test.
Oh, okay. All right. You sent me one more email, right?
I did.
Open it up. Hold on.
Yeah, so we need, for this one, we have to do 17, 18, and 20.
Okay. So they give us the picture. Determine the width of the walkway if the area of the walkway is 707.
Yep.
Oh, Jesus. This is 20 by 27. And this is what? 28 by 27? What is that number?
The first shaded box is 27 by 20. The second one's 27 by 30.
Okay. A walkway of uniform width, and the only thing we need to know the width if the area equals 707. So let's assign a variable.
X equals...
the width of the walkway.
Yeah.
So that's X, that's X, that's X, that's X, that's X. So if we want the area of this walkway, there's a couple of ways we could do it. We could divide it into a few rectangles. Or is there an easier way to do it? There might be an easier way to do it. Notice that there are a couple of ways we could do it. We could break it up into a bunch of rectangles. And we pretty much know the dimensions of all those rectangles as a function of x. And we would have an equation that 707 is equal to some quadratic. We'd have to solve it for x.
Yeah.
But personally, I like a better way of doing this. The area of the walkway is what? It is the area of the big rectangle minus the area of the two little rectangles. Right?
Yeah.
What's the area of the big rectangle? So the area of the big rectangle minus the area of the big swimming pool minus the area of the baby swimming pool. So what's the big rectangle? What's the length?
Is it 3x?
Plus this. So it's 50 plus 3x.
Oh.
So it's 50 plus 3x times what?
27 plus 2x.
Notice that gives us a quadratic minus the area of each of these. The area of that one looks like 5,400.
Okay. Yeah, I'll grab.
The area of that one looks like 8110. I got too many zeros in there. That's 540. There we go. And all of that is equal to 707, right?
So this one is a minimum, doesn't it? Not a maximum.
Well, we're going to solve for x, so it's not either. In other words, x is we're going to come up with two values for x. Most likely one of them is going to be negative, one of them is going to be positive. We'll use the positive one. So this is a quadratic that you need both solutions. But in order to get it, we're going to need to do some foiling. So let's see, we got 707 equals 1350 plus 100x plus 81x, 181x plus 6x squared minus 1350. Well, that's nice. And so the quadratic that we have to solve is 6x squared plus 181x minus 707 equals 0. You know how to solve this on your calculator?
Yeah, I believe so.
Okay. Go ahead, come up with a couple of answers, and like I said, I'm sure, yeah, one of them has to be positive and one of them has to be negative just based on that. That negative 707.
Could we factor this?
By hand? Possibly, but it could take like a half an hour to try all the combinations.
Yeah.
So this is probably why she said all your computer problems are doable by let's see, I'm trying to get to my, so if I put this in, let's see if I can factor it while you're doing it also.
So am I trying to find the vertex?
No, you're trying to solve for x.
So would you graph that first equation and then just graph 0 and see where they intersect?
Yeah, that's a good way to do it. Yeah, find your zeros. Find the zero that's the positive zero, which is your answer. You don't even need to worry about the negative zero. Let's see what I did wrong. Apparently.
I got a 0 at 3.5 comma 0.
Okay, hold on 1 second. I'll give you what mine is. Seven halves, 3.5.
3.5 comma 0 is what I got, yeah.
So 3.5 is your answer.
Yeah,
Your other zero, I'm curious about your other zero because I got a negative. In other words, when I factored this, I got 2 times x minus 7, or 2x minus 7 times 3x plus 101. So it actually does factor. And then if you solve each of those, you don't get 0 as the second zero. You get minus 33 2/3. But the positive 0 is at 3.5. So that has to be the answer. $18 next?
Yeah. So the answer is 3.5 for 17?
Yeah. Is this a male teacher or a female teacher?
Female.
Okay, this is a similar problem as the corral next to a house.
Yeah.
Okay, so we have 2,400. Here's, am I reading this correctly? This is the house, right? No.
Yeah.
So our fencing has to cover all of our lines here? All of our vertical lines and both horizontal lines?
Yes. It says the farmer must keep the animals separate, find the greatest possible area of the pen that houses all the animals. What are the dimensions of the pen with the greatest possible area?
Okay. So this is where our fencing goes.
Yeah.
4 different areas. Okay, so how should we proceed?
Let the width be x.
Hold on a moment. These aren't equal areas, are they?
No,
They're
I
not.
don't think so.
And it doesn't matter. You're right. We can let the entire width be x and the entire height be y. So now what kind of equations can we write?
would we have to do the area of all of those?
Well, first of all, we know we have 2,400 yards of fencing.
Yeah.
So let's get an equation for that. 2,400 is equal to what?
X times Y.
No, that's area. We have 2,400, so each of the lengths of these lines has to add to 2,400. So we have a Y there, we have a Y there, we have a Y there, and a Y there, and a Y there, and we have an X up there. So the fencing, go ahead.
Is it 5Y plus 2X?
Uh-huh. Okay, so that's one equation. The equation we want to maximize is what?
To maximize?
Yeah, in other words, they're asking us how do we build this thing to give us the most area, right?
Yeah.
Okay, so the thing we need to figure out is what equation is it that we want to maximize? We're maximizing area. Area is what?
Base times height.
X times Y.
Yeah, X times Y.
Okay, now the reason we can maximize this is because we can take this other equation, solve for Y, and substitute it in over here. So now area will be a function of only X, and we can find the vertex of that quadratic.
Okay.
So let's do that. Solve this one for Y.
Alright, so 5Y equals 2,400 minus 2X. And then divide everything by 5, and you get Y equals 480 minus 2/5 X.
Okay, now let's go over to the area function, the one we're going to maximize. And that's equal to X times, instead of Y, we're going to put in this over here. Notice we're going to have a quadratic. We're going to have an X times an X. That's an X squared, so we're going to have a quadratic. Vertex is going to represent the maximum area.
Okay.
So X is what? Hold on a second. I think that spider did crawl up my leg. Dang. Okay, what?
The area is 480X minus 2/5 X squared.
Okay.
Alright, let's graph this.
I think the key on choosing the window to graph these is looking at this number right here. You probably want to make your Y coordinate go up to that, in that range, I would think. Tell me if you need me to do it also. Well, it's too bad they don't have a function that you could just hit so that it would always show you the vertex and it would label itself.
Yeah.
And then you could just zoom in or out as necessary.
Alright, so the zeros are...
And you want the vertex, not the zeros.
Oh wait, yeah, sorry.
Because this we're maximizing it. Whenever you see those words maximize or minimize, know that it's going to be a quadratic and that you're going to be looking for the vertex.
All right, so the vertex is 6. That's a big number. 600, comma 144,000.
So what was the question? The question was, what are the dimensions of the pin with the greatest possible area? So X was 600.
Yeah.
So now we need Y because we need the full dimensions.
So
Actually, can you read Y off there? Well, you got Y. No, Y is the area. We need the dimensions, so you got to go back to this formula, substitute 600 for X, and solve for Y.
in the first formula or the second?
The first one. Because, well, I guess you could use the second one since you know that it's 144,000. Yeah, let's use the second one. It's actually easier. So what is 144,000 divided by 600? That's Y.
240.
So that's the dimensions. Each of these are
All right,
240, and the whole thing is 600 wide.
Don't erase that just yet.
Okay? You want me to show it all there?
Yeah. All right, that's good. Hold on. All right, that's good.
Okay? And 20, right?
Yeah. These ones are easy. They just are a pain to type into the calculator.
Yes. All right. So, we know the surface area, right? We don't know the surface area, but we know the dimensions of each side. What is the, let's see, the volume is equal to, what do you use, width, length, and depth?
Width, length, and height.
Width, length, and height, okay? And width is x plus 3.
Yeah.
So it's x plus 3 times x plus 4 times x plus, I can't read that last one, 1?
X minus 1.
X minus 1. Okay, so that's our volume. And our surface area is what?
What is the formula for surface?
Well,
oh wait, hold on, I remember
it's
this.
the sum of all 6 surfaces.
Yeah.
What's
So
the
the
sum? What's this first area here?
That's x plus 3 times x minus 1. But you have to do that twice because there's 6 faces.
Right.
So in the calculator, you have to put in 2, and then the x plus 3 and the x minus 1. You have to do that for each of those.
Just know that you have to do all combinations you can do. And the last combination is x plus 4 times x minus 1. And they've given us the surface area, correct? 779.5.
Yeah.
So I can erase this SA and write 779.5. Now we have a quadratic that we're going to have to solve. We know it's a quadratic because that's going to produce an x squared, that's going to produce an x squared, so is that. We add them all together, we're still only going to have an x squared. So you want to find the zeros of this function. Now, could you you could probably type this in exactly as I show it here, couldn't you? 779.5 equals all of that?
Yeah, that's what I did.
It'll graph it and give you the zeros. So what do you get for the zeros for x?
I made one mistake real quick. I need to type.
Again, you're probably going to get a positive and a negative number. Notice that no negative numbers could work because that height is x minus 1. Negative x's could actually work for the width and the length.
So how can you graph this? How do you find, like, I graphed both and then you're supposed to find the intersection of the two, right?
No. Well, you can graph it as one quadratic by moving the 779.5 over to the other side and then find the zeros of that single function. Or you can graph it as two functions, this being function 1 and this being function 2, and then you find the intersection.
Yeah, that's what I just did, and I got 9.5, comma 779.5.
9.5? You should have gotten two different zeros.
I mean...
No, we're not looking for the vertex. We're looking for the zeros because we're looking to solve for x. Doesn't have to be two different ones, but the only time you're ever going to get precisely one answer is if the parabola comes down and just touches the x-axis. Then you would only have one zero.
And then for the other one, I got negative 13.5, comma 779.5.
Okay, so the negative one we throw out.
Yeah.
So this is x, and then to figure out the volume, just go back, substitute that into there, come up with a volume number. 12.5 times 13.5 times 8.5.
Alright, hold on, let me write this equation down real quick. Alright.
Well, 19 looked fun. How come they didn't let us do 19?
We haven't talked about that yet.
Okay. All right. You good to go?
Yeah, I think so.
All right. Let's see. When are you scheduled next? Let me have a look at my calendar here. Saturday at noon? Is that right? Yeah.
Yeah, and then if anything changes, I'll just let you know about for that.
Yeah, that's fine. All righty.
All right.
Have a good week, Jackson.
You